looking at number 1 on section 8.3 here. We're going to try and figure this out together. So anyway, the series was given by, wherever that is, I'm past it. It's the series 1 to infinity of what? 1 over 2n plus 1, 2n minus 1? Is that page 706? 2n minus. Is find the first 4 elements of the sequence of partial sums and find a formula for the first for S sub n in terms of n. Okay, well, what's S sub 1? Let's just that's adding up the first one, right? So let's just do this kind of basics here. We plug in n equals 1 because n equals 1 to infinity. It's just the first term. So A1, S1 is A1, right? So this is going to be plug in 1, and we get 2 minus 1 is 1, and 2 plus 1 is 3. So this ends up being 1/3, right? Everybody good with that? So what's S sub 2? S sub 2, the second partial sum is A1 plus A2, which is going to be 1/3 plus, and then when we plug in 2 to this sequence, we're going to get 1 over 4 minus 1 is 3 times 4 plus 1 is 5. So 3 times 5 would be 1/15. Is that correct? And then, of course, we can get a common denominator. That's 5/15 plus 1/15 is 6/15. And then, of course, that reduces to, if we divide top and bottom by 5, 2/5. So we get 1/3 for the first one, 2/5. We can keep going that way, right? You follow where I got that or not? And then, should we do one more? We'll do S sub 3. Well, that's A1 plus A2 plus A3. This is, and I know they asked for like the first 4. But anyway, the A1 plus A2 we already have is 2/5, right? So there's no use keeping them written different. And then plus A3. If I plug in n equals 3 up here, I'm going to get 1 over 6 minus 1 is 5 times 6 plus 1 is 7. So this is plus 1/35. Everybody agree? And 2/5, of course, is how many 35ths? 14, right? So this ends up being 15/35, which is 3/7. Okay, so that's the value of S sub 3, the third partial sum. So really what this equals then, this infinite series, is going to equal, if we write this out, it's 1/3 plus 2/5 plus 3/7 plus, now we're kind of seeing a pattern. What do you think the next one might be? It might be 4/9 because we have an arithmetic sequence on top, 1, 2, 3, 4, 5, it increases by 1, and we have an arithmetic sequence on the bottom, it's increasing by 2 each time. So it could be the case that this is 4/9. Okay, could be. So I'm going to put a question mark. I'll let you verify that, but I'm pretty sure it is. Anyway, and then plus dot dot dot. Whoa. Plus dot dot dot. Keep going, and then the nth term, right? So 1 over, and this is where I liked using k's, but anyway, the book uses n here. So that one, right? But then we keep going, right? Plus dot dot dot. So it keeps going. So this is actually a written out version. Right? Okay, now, if that's the pattern, there's a couple of things. So I'm gonna spend 5 minutes on this problem if you're okay with that, because we're gonna try and figure out what's the best way for us to do that. Is it to recognize the pattern, or is it to try and do some algebra to figure out the value? Because that does not match the answer in the back of the book. This is a correct answer in terms of n, isn't it? But it's not very specific. So the value of the nth term, to get the value of the nth term, let's say I want the value of the 100th term. Is there an easy way to figure this out? Not really. You'd have to add up 100 different numbers, right? And you'd have to figure out what they all are. So that's not what it's asking. I think it's asking for a formula to actually calculate the value of the nth partial sum. Does that make sense? Okay. So anyway, so what's on top? On top is n, right? So when n is 1, when n is 2, when n is 3. Right? So the on top would be n, and what's on bottom? Well, it could be n plus 2 for the first one, but n plus 2 doesn't work for the second one. 2n plus 1 kind of looks like that. 2n plus 1. So does that work? Yeah. For the second term, 2 times 2 plus 1 is 5. Third term, 2 times 3 plus 1 is 7. Yes. So this would be, and is that what they had for their? That's what they had for their deal, right? So what the back of the book had. Okay, so we. Oh, this is excuse me. This isn't. That's the series. Okay, but this is the value of the. That gives this number, right? That's S sub, this is S sub n. So the value, am I not doing this right? I mean, that's the answer, but that's the value of the nth. So like if n is, oh, no. Wait a minute. I wrote this wrong up here, didn't I? I wrote this wrong. I completely wrote this wrong up here. That's why I'm getting confused. This part up here is not what this equals. It is not equal to that, is it? Because this is the first sum. S sub 1 is 1/3. The second sum is 2/5. But if I take the sum of the first two sequences, let me use a different color here. So I apologize for that. It's 1/3 plus 1/15. A1 plus A2, this is A1 is 1/3, A2 is 1/15. But the value of the second partial sum is 2/5. So this stuff over here, this is wrong. Sorry, all this over here, like that's not what it is. Huh? How's that wrong? Because I'm adding up the sums, which is not what this sigma notation is doing. The sigma notation is A1 plus A2 plus A3, right? So A1 is 1/3. So if I was writing this out, it'd be 1/3. That's the first one. And then the second one is 1/15. Not. I thought the second one was A1 plus A2. That's S sub 2 is. That's the second partial sum, which is A1 plus A2. If you're adding up an infinite series of terms, it's the A sub i's. So it's 1/3 plus 1/15 plus the next one plus 1/35, etc. So I wrote that wrong. But anyway, so this is true. I guess where I was getting hung up is like, well, aren't I adding stuff? No. So the value at the end, the 2/5 and the 3/7 and the 1/3, those are the partial sums. S1, the first partial sum, S2, second partial sum, S3, the third partial sum. The nth partial sum actually works out to be n over 2n plus 1 because we noticed a pattern. I will record another session that shows you an analytical way to come up with that. We recognize the pattern. So what if you don't? What if you don't get lucky and notice a pattern there? You need another method to come up with that answer. Then we take the limit as n goes to infinity. As n goes to infinity, what dominates this? So we just take the limit as n goes to infinity. Here, let me clear it quick. The limit as n goes to infinity of n over 2n plus 1. No, you just divide everything by the biggest power of n. Of s sub n, yes. So it's the limit as n goes to infinity of s sub n. Yes. Because that's the nth partial sum. And then what happens when the partial sum, when we go farther out? We divide everything by n. This goes to 0 for this one. This is 1, and this is 2. So it ends up going to 1/2.